Hey guys, this is going to be the video version of my Wireshark workshop walkthrough. I'm pretty horrible at introductions, so I'm just going to go ahead and get started. Let's go ahead and open the Wireshark PCAP file that I'll be giving to all the students. Just go ahead and drag this over. Now, the first thing you'll notice is that there's a lot going on right here. Just to kind of take a look, let's look at the interface. So we have all columns here. The numbered column, so this is just the sequential order in which the packets have come in. We have this time column, which is the relative time that we received the packet since the packet capture began. Source IP address, destination IP address, protocol, so TCP, UDP, SSL. We can even filter this down by, say, DNS or HTTP for web traffic. Go ahead and clear that. We have the length, so how long are the packets, and a little bit of expert info as just kind of side comments. We can even go in here and right-click, column preferences, and add our own column. So let's go ahead and add a new one. We're going to use this in a little bit. Call it stream ID. And the field is going to use a filter. I'm going to go over filters in a little bit. In the meantime, this will help keep us a little organized. So let's do tcp.stream and move this. You can just drag it. Let's move it next to the length field. Okay. You can see the stream ID is now populated based on the TCP packets going back and forth. On the bottom, you'll see the expert info. Let's make this simple. Filter by HTTP. Let's take a look at our first GET request here, get/HTTP 1.1. We can click on this packet. So we see the expert info with the hypertext transfer protocol. We can expand that and see things like this is a request to yahoo.com. The person who made the request is using Mozilla, which is usually Firefox. And this cookie holds all the session data. Now, if we wanted to drill even further, we can see all of the information that was being passed back and forth from this GET request to the website. You can even see down here on the bottom the bytes, the individual bytes and what made up the packet, just in case we need to do some protocol analysis. Let's go ahead and take a look at the scenario. So you are the security engineer at Air Guitar Incorporated. They sell air guitars, and have just been alerted that an intruder has entered your protected network through a rogue device. You hypothesize they may have used the device to connect to an internal server and stolen secrets. The internal server has had its logs erased, and the attacker is no longer on the network. Fortunately, you have a packet capture of the activity, the address of the attacker system, 192.168.1.18, and the address of the internal server, 192.168.1.17. Your objective is to figure out how this attacker got into the server and recover evidence, including how did the attacker get into the server? What commands were run by the attacker? What were the names of the files that were stolen? What were the contents of the first file? What were the first 4 bytes of the second file? And then what were the contents of the second file? To get started kind of tackling this scenario, what we're going to need to do is go over the PCAP analysis methodology. What you're looking at is a needle in a haystack. You need to begin by knowing what you're looking for. And you start with pattern matching. You need to identify and filter packets that are interesting by some sort of specific value or protocol metadata, which means that we just need to filter out all the chaos and find what we want to look at. You want to list the conversations and list all the streams within the filtered data. You want to isolate and export the specific conversations of interest. And then from that information, you want to be able to draw some conclusions. In this particular case, we want to be able to answer how the attacker got on the server and what they stole and what information can be found in there. So let's go back to the PCAP. Let's go ahead and clear out the filters. So we want to filter based on the information that's important. We want to see the communication that's happening between the attacker's address and between the internal server. So the filter for this is ip.addr equals. Actually, you know what? I'm going to start with this. I'm going to go here and select statistics, conversations, and I want to see information being sent to, nah, that's dumb. That'll just confuse them. So we want to filter. The filter by IP address, we want to look at ip.addr and then equals 192.168.1.18, which is the attacker address, and the victim, the internal server, addr equals 192.168.1.17. I'll select all of this. I'm just going to copy this because we're going to go back and forth a couple of times and paste that into my filter. So now we can see that everything's been filtered by all conversations relating to the attacker's PC and the victim internal server. First thing we want to figure out, how did the attacker get in? Well, a good place to start would be the first few conversations that the attacking machine had with the victim machine. So let's take a look and actually see what kind of packet data was going on between those two systems. So we right click, go to follow, and then TCP stream. This is the first connection between the attacker machine and the victim machine. We can see the source address as this 1.18 and the destination as the 1.17. So we have the source address as the attacker, so the attacker is communicating to the victim machine. The attacker's in red and the victim will be in blue, based on this source and destination pair. And if we search through and read for anything that seems interesting, we can see Java RMI server, and it's the attacker sending this Metasploit RMI loader, and it's trying to send this address http:// and it's the same address. It's the attacker's address. So it looks like there may be a link on port 8080 of the attacker that they're trying to get the victim machine to connect to. Let's see if I can zoom this in. No, I can't zoom this in, so I'll just have to, oh, there we go. I can zoom this in, make it look a little bit bigger. So we see the Java RMI server and the Metasploit RMI loader. Let's close this, go back, re-input the filter, and that was stream 143. I should have shown this earlier. So when we follow TCP stream, and and this is where having those stream IDs are important, is that everything with the 143 is what gets filtered, and it shows what the conversation looks like. So if I want to ignore or go back through, I see 143, 143. So the next communication between the attacker and the victim is this 152 stream ID. So let's go ahead, right click, follow TCP stream. And sure enough, it looks like it is downloading this .jir file on the host 192.168.1.18, which is our attacker, on port 8080. And it's sending this payload, this Java archive, back to the victim machine. So it looks like it's installing possibly a virus. We see Metasploit, which is a well-known exploit framework. It's designed to send and submit viruses. So we're pretty confident that that's how the attacker got in. Let me go ahead and close this. Let's go back. And so 143 and 152, we already took a look at. Here's 158. Let's see what else is going on. And there's all sorts of conversation stuff. We see the source is 192.168.1.17, so this is going to come up in red. The source is always in red. And the destination, 192.168.1.18, is going to come up in blue. So all this conversation, all this information is coming from the attacker machine to the victim machine. We see some interesting text here at the bottom. We see who am I, and the victim machine replies root. We see uname-a, the victim machine replies Linux Metasploitable 2.6 server. So it looks like the attacker was able to run some Linux commands. We see nc-w1, and then the attacker machine -p12345, and it's sending in this etc password file. Now for those of you who are unfamiliar with Netcat, Netcat is a basic network utility that some people use to send files from one device to another, or sometimes commands from one device to another. And so what it looks like this is doing is it's sending a file from the victim to the attacker on this port 12345. And it looks like the first file name is /etc/password passwd, and this second file, again doing the same thing, is this /root/a.out, and then the last command they run is exit. That answers questions 2 and 3. What commands were run by the attacker? So we see who am I, uname, and netcat, and then exit. Netcat twice. What were the names of the files that were stolen? So the first file was this passwd file, etc passwd. And the second file is this root a.out. Now we want to take a look and see what were the contents of the first file. So we can close this and do a new filter, because we want to see the address of the attacker 168.1.18 on the port 12345, since that's what we saw in the output that was given. So ip.addr equals 192.168.1.18 and tcp.port equals 12345. We can copy that. I'm using this notepad for readability. It's kind of difficult to see everything at once. I also have this really bad habit of zooming out of my Wireshark as much as I can, just to kind of capture everything. Now we see, trying to scroll through here, this seems like everything we have. So we see this stream ID 384, this is a new one, and 520. So it's pretty good bet that this is the first file, this 384, and the second file is this 520. So let's take a look at the first file. Follow TCP stream. And we can see that indeed this is the etc password file. We can see root, daemon, bin, sys. If we kind of look through here, we see Tomcat55, MySQL, the FTP user, www data. We can even see MSF admin, which is the username, SNMP. So we can see all of the usernames. And if the attacker wanted to, it looks like they would be able to pull off the password files as well, or see all of the users' passwords. But it doesn't look like they took that opportunity. So let's go ahead and go back and take a look at the second file. Right click, follow, TCP stream. I see that a lot of this kind of looks like gibberish. The fifth question that we were trying to answer is, what were the first 4 bytes of the second file? What we're going to do is change this show and save data as. We're going to go ahead and look at the hex dump so that we can get the numbers, and we see the first 4 bytes are 7F, 45, 4C, 46. And if we were to try and read that, it looks like period ELF. Now, this is what's called a binary. It's all basically ones and zeros that when you put them together in the right order, create a file. So what we're going to do is called network file carving. To do that, Wireshark makes it very simple. Just change this show and save data as. We'll save it as raw data. Yeah, we'll save it as raw data. And we only want the conversation from one side. We can see that everything coming from 192.168.1.18. This is kind of hard to see. On port 12345 going to .17 is 0 bytes, but we want to grab everything going from .17 to .18. So we just click on that down here. Save as. I'll go ahead and save this. I don't know what extension this is, so I'll go ahead and save this as file.dump. We can go ahead and close that. Now what we want to do is open the file that we just extracted. I'm going to go down here and click on my Sigwin. In the final version of this presentation, what I'm going to do is recreate the PCAP file, except instead, this is a binary, this is an ELF binary. I'm going to do this with a PDF, so it's really easy to open. We already know what the extension is, and I don't have to do this extra step. So this is kind of an extra step just to kind of show for completeness what the file was in this test PCAP that I gave you. So I'm going to go ahead and change my directory to where I'd saved the file. cd sig drive c users documents workshop. And here's this file.dump that I saved. So Linux has a really cool utility. Again, this is a little bit of extra information, but Linux has this really cool utility called file. it'll tell you what kind of file it is. So let's just type in file and then file.dump. And it says here that this is a ELF 32-bit LSB executable, which means that it's a Linux file. And Cygwin is awesome because it allows you to run a Linux terminal emulator in Windows. So I can just go ahead and run it. Oh, exact format error. Alright, so it just doesn't want me to run it. That's fine. I'm not too terribly worried about it. But that's the file extraction section of the workshop. So I'm going to go ahead and just minimize that. So that's great. We were able to answer all the questions that were presented to us. How did the attacker get into the server? The attacker used Metasploit to exploit a Java RMI server that we saw in the first few packets that we took a look at. What commands were run by the attacker? The commands were whoami, and the result was root, uname-a, which is the name of the Linux server, or how to pull up the name of the Linux server. We saw that it was Metasploitable. What were the names of the files that were stolen? It was /etc password and /root a.out. What were the contents of the first file? Well, that was the etc password file, which contained the list of usernames and other parameters. What were the first 4 bytes of the second file? That was period ELF. I don't remember the hex off the top of my head, but we can grab that really quick. Change that ASCII to hex dump. That was 7F454C46. And what were the contents of the second file? I wasn't able to open the file, but if you guys are bored, it's a small capture the flag exploitable, or a small capture the flag challenge. So go ahead and try that out and see if you can figure out the challenge. I want to take a moment and just kind of tie this back into the PCAP analysis methodology. So what we did is we performed pattern matching. We started off by filtering out all of the packets that weren't relevant to information traveling between the attacker and the sender PC, or the attacker and the victim PC. We listed those conversations, and that was the right-click follow TCP stream. Or, sorry, that was the viewing the stream IDs themselves. We exported and isolated the conversation streams of interest. So, for example, these were the streams for the files, the stream ID 384 and 520. And then we drew conclusions based on what we found within them. And those are some things that you can do with Wireshark. Using the same methodology and some practice, you can even start competing in the DEF CON forensics competition. In the final version, I'm going to add links to the forensics contest and the honeynet.org contest, where you can actually do and complete the first few challenges using this exact same methodology and everything that I covered here. So I'm going to cut the video now. I'm going to add the introduction later. That's probably going to be about 5 minutes, and then I'm going to leave the rest of the time for questions. At this point, I started the timer as soon as I started speaking, and I'm at 24 minutes and 30 seconds. So I think Ed will be really happy I'm able to complete all of this walkthrough. If there's no incredibly difficult questions to answer, in less than the amount of time that he asked for. So I hope this video helps, and have a good night.